Hello everyone, this is our session 11 on differentiation. We were doing exercise 1.2 on question 7. Okay, so I'm beginning with question 7. The last two questions were remaining, 2 or 3. So let me start with question 7, the 10th one, right? So the 10th question says y is equal to tan inverse of root of 1 plus cos x upon 1 minus cos x. This is fairly simple. Remember, we had done 1 plus cos x and 1 minus cos x formulae, so we can say y is equal to tan inverse of, okay, bracket, now root of 1 plus cos x will be 2 cos square x by 2. 1 minus cos x will be 2 sine square x by 2, right? So 2 cancels out, you're left with tan inverse of bracket root of cot square x by 2. So we have tan inverse of cot x by 2. What we have to do is use complementary functions. So we can say y is equal to tan inverse of tan pi by 2 minus x by 2, right? So we'll have y equal to tan inverse of tan will be the angle itself. So my pi by 2 minus x by 2. Now dy by dx. So dy by dx is equal to, the first term is a constant, so 0 minus half. So the answer is minus half. Okay. This is question 7, the 10th one. Now I'm doing the 11th one. So 11th one we have y is equal to tan inverse of cosec x plus cot x. This is also simple. Just convert cosec x and cot x into the basic trigonometric function. So we'll have tan inverse of 1 upon sin x plus cos x upon sin x, right? So we'll get 1 plus cos x upon sin x, correct? Which can be written as tan inverse of 1 plus cos x is 2 cos square x by 2, right? And sin x can be written as 2 sin x by 2 cos x by 2, right? So 1 cos cancels out, 2 cancels out, sorry. 2 cancels out and 1 cos cancels out. So we have tan inverse of cot x by 2 left with us. Tan inverse of cot x by 2 left with us. So we'll say tan inverse bracket tan pi by 2 minus x by 2, right? So we have tan inverse tan will cancel out and we will be left with pi by 2 minus x by 2, differentiating which we will get dy by dx is equal to minus half, right? So that is your 11th one. We move to the next one, the 12th question. 12th question is y is equal to cot inverse of, and then we have root of 1 plus sine 4x by 3, right? Plus root of 1 minus sine 4x by 3. Same, root of 1 plus sine 4x by 3 minus root of 1 minus sine 4x by 3, right? So close the square bracket. This is our question. Now, what do you think it looks like? It is like a minus b and a plus b. So let's rationalize it. we'll multiply and divide by the opposite of the denominator, that is 1 plus sine 4x by 3 plus 1 minus sine 4x by 3. So we'll have to write over there multiply and divide by root of 1 plus sine 4x by 3 plus root of 1 minus sine 4x by 3. Okay. Basically, we are rationalizing over here. So you'll get y is equal to cot inverse of, okay, bracket. Now, if you multiply the numerator, you're going to get a plus b the whole square. So root of 1 plus sine 4x by 3 plus root of 1 minus sine 4x by 3, right? This is your angle. This whole thing square. Yes. So this is your square. Yes. And denominator will be, now this is a minus b already in the denominator and we are multiplying with a plus b, right? So what are we going to have as the answer? So it is a square. So 1 plus sine 4x by 3, the root sign will go off, minus b square, again the root sign will go off, put a bracket, and the sign will also change, so minus 1 plus sine 4x by 3, right? This is a plus b, a minus b multiplication, okay? Now the numerator expansion, it is a plus b the whole square, so we'll get y is equal to cot inverse of, okay, a plus b the whole square. So a is a square plus b square, so 1 plus sine 4x by 3, right? This is a square, the root sign goes off, plus b square we'll put in, so 1 minus sine 4x by 3, right? Plus 2ab. Now 2ab is 2 root of 1 plus sine 4x by 3 root of 1 minus sine 4x by 3, correct? Let's fit it in one line. So yeah, and the denominator, one second, sorry. The denominator will be 2 sine 4x by 3. Okay, this is your denominator. Now we can write this as y is equal to cot inverse of bracket. Now what all will get cancelled? So plus sign, this gets cancelled. We get 2 plus 2 AB. Now look at A and B. It is in the bracket 1 plus sign, 1 minus sign. So A plus B, A minus B. So we'll put the root sign and we'll do A square, that is 1 square, minus B square, that is sine square 4x by 3. Okay. And denominator is 2 sine 4x by 3. Right. So we've used A plus B, A minus B multiplication. Now we'll take 2 common. So we'll get y is equal to cot inverse of 2 common bracket 1 plus. Now 1 minus sine square is cos square. So cos square 4x by 3 root sine. So we'll have only cos 4x by 3. Okay. Divided by 2 sine 4x by 3. Right? 2 cancels out. 1 plus cos can be written as 2 cos square x by 2, right? So cot inverse of 1 plus cos theta, 2 cos square theta by 2, so 4x by 6 divided by Sine theta can be written as 2 sine theta by 2, that is 4x by 6 cos 4x by 6. Cos cancels out. We are left with cot inverse of bracket cot 4x by 3, right? Sorry, 4x by 6. Yes, so cot inverse of cot is 4x by 6. Here the formula used is since 1 plus cos theta is equal to 2 cos square theta by 2. Okay. And sin 2 theta formula, that is 2 sin theta cos theta. Now cot inverse cot is 4x by 3, the angle itself, so 4x by 3. Okay. dy by dx then will be equal to, sorry, 4x by 6. Every time I'm writing the wrong thing. So dy by dx, 2 by derivative of x is 1, so 2 by 3 is the answer. If this was the 12th question of question 7. Okay. Now we're moving on to exercise 1.2, question 8. Okay. So let us start with question 8. It says differentiate with respect to x and y is equal to sine inverse of bracket 4 sin x plus 5 cos x upon root of 41. Okay. So there is a method of solving this kind of sums. I'm doing one sum. All the remaining sums of this part of the questions are same. Okay, so I'll just show you the method for this one. What you do is you will segregate the denominator, that is separating the denominator, giving it to each of the numerators. So 4 upon 41 sin x plus 5 upon root of 41 cos x. Okay. Next step, we say that let 4 upon root of 41 equal to cos alpha and 5 upon root of 41 equal to sin alpha. Okay, now we are assuming them to be cos alpha and sin alpha, right? So we have to prove whether we have taken the correct trigonometric ratios. So how do we do that? So we find out sin square theta plus cos square theta for them. That is sin square alpha plus cos square alpha, okay, is equal to 4 square, that is 16 upon 41 plus 25 upon 41. So what are we getting? 1. So that means it's true. They are a part of a right angle triangle, right? And so we can write tan alpha as sin upon cos. So what is sin? It is 5 and cos is 4. So 5 upon 4. Therefore, alpha is equal to tan inverse of 5 by 4. Correct? Now, let us come back to the question. So we are going to substitute 4 by 41 as cos alpha and 5 by 41 as sin alpha. Okay, so let us substitute. So y is equal to bracket cos alpha sin x plus sin alpha cos x. Okay, we can, sorry, there is an inverse function here. 1 second. Y is equal to sin inverse, right? So sin inverse, this can be written as sin x cos alpha, okay? Sin x cos alpha plus cos x sine alpha. This is the formula for what? Sine of a plus b, right? Sine of a plus b is sine a cos b plus cos a sine b. So we can write this as sine inverse of sine of a plus b, so x plus alpha. Okay, using sine of a plus b equal to sine a cos b plus cos a sine b. Okay, so this is sine inverse sine will be what? X plus alpha. Correct. What is alpha now? Alpha is tan inverse of 5 by 4, so which is equal to x plus tan inverse of 5 upon 4. This is your y expression. Now we'll differentiate this. So y is equal to x plus tan inverse of 5 by 4. So dy by dx is equal to, what is the derivative of x? 1. And derivative of a constant term, that is tan inverse 5 by 4, will be 0. So the answer is 1. Yes, so we've struggled a lot to just get this 1 as an answer. Okay, let us move on to question 9, because I said that whatever questions are there in the 8th part of the exercise are just the similar type. So if you have any doubts in that, you can refer to this one example and solve it according to this. If not, then do write to me. Okay. Then question 9. Question 9, what do we have to do? So it's differentiate again with respect to x. So let's take the first question of question 9. Okay. It says y is equal to cos inverse of 1 minus x square upon 1 plus x square. Okay. So here we are going to use some identities of cos 2 theta, cos 3 theta, and solve the sums. So we need to remember these formulas. Every time I'll be using it, I'll put down the formula there. Make sure you have a list of it all together, because that's what we refer to while solving these sums. Okay. So let's start with this. We'll say let x equal to tan theta. Now when x is equal to tan theta, then theta is equal to what? Tan inverse of x. Okay, remember this. When you write something, when you're substituting something, don't forget to write its inverse function. Okay, so then y is equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. Now, what is this identity for? It is for cos 2 theta. Okay, so I'm going to write this over here, cos inverse cos 2 theta. Okay, and in brackets we'll write 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. Okay, and this is what we have used over here. Now what is cos inverse of cos? It is the angle itself, right? So we'll say y is equal to 2 theta. Okay, since cos inverse of cos theta is equal to theta. Okay, so I've used that property and I've put y equal to 2 theta. Now we have theta equal to tan inverse of x. So we are going to substitute that in this. So y is equal to 2 tan inverse of x. Now we do dy by dx. Now it becomes simpler. So dy by dx 2 as it is. Tan inverse x is 1 upon 1 plus x square. So the answer is 2 upon 1 plus x square dy by dx. Right? So this was question 9, the first one. Now the second one is also a similar pattern. I'm just solving the initial part of it. You'll come down to the same answer. Okay, let's see second one. Second one says tan inverse of 2x upon 1 minus x square. Okay, again I'll say let x equal to tan theta. Okay, so theta will be equal to tan inverse of x. Okay, so let us put it in the sum. So we'll have y equal to tan inverse of 2 tan theta upon 1 minus tan square theta. Okay, this is equal to, now what is this formula for? 2 tan theta upon 1 minus tan square theta. It is for tan 2 theta. So we'll say tan inverse of tan 2 theta. Okay, and here we can put it in brackets, since 2 tan theta upon 1 minus tan square theta is equal to tan 2 theta. Okay, now what is tan inverse of tan? It is 2 theta, right? And so again we'll put y equal to 2 tan inverse of x, is substituting theta again, so tan inverse of x. So the answer for dy by dx will be equal to 2 upon 1 plus x square. That is tan inverse x derivative. Okay, here we can write, since tan inverse x or d by dx of tan inverse x is equal to 1 upon 1 plus x square. So I've used that formula and I have got the answer. Clear? This was question 9, second one. Okay, let's go to the third one. So it says sine inverse of, here it's basically we should remember our identities and so sum becomes simpler. You know, this is sine inverse of 1 minus x square, 1 plus x square. Again, it's the same step, x equal to tan theta. Okay, so we'll have theta equal to tan inverse of x, right? And we'll substitute it in the sum. So y is equal to sine inverse of bracket 1 minus tan square theta upon 1 plus tan square theta, right? Which is the formula for sine 2 theta. So sine inverse of, the formula for cos 2 theta. So cos 2 theta. Okay, just writing the formula here. So 1 minus tan square theta upon 1 plus tan square theta is equal to cos 2 theta. Okay, and that is why I've substituted it over here. Now you can see that they are opposite functions. So what we have to do, we have to write it in complement form. So sine inverse of bracket sine of pi by 2 minus 2 theta. Correct? So we'll have y equal to, what is sine inverse of sine? It is cos. Sorry, what is sine inverse of sine? It is theta itself. Pi by 2 minus 2 theta. Pi by 2 minus 2 theta, yes. So when you take dy by dx, right, we'll have pi by 2 is 0 minus, what is 2 theta? It will be 2. Theta is tan inverse of x, so 2 tan inverse of x. We have to find the derivative of this, right, like this, yeah. So dy by dx is equal to minus 2 upon 1 plus x square, because tan inverse x derivative is 1 upon 1 plus x square. Okay, this is question 9, third one. Let's move on to the fourth one. The fourth one is y is equal to sine inverse of bracket 2x under root of 1 minus x square. Okay, we can say again, let x equal to, now here the formula will change. If you observe, you don't have a numerator denominator, you have 1 minus x square. So if you have 1 minus sine square, it becomes cos square. So can I take x equal to sine theta? If I take it as sine theta, then theta is equal to sine inverse of x. The point is that how would I know what is the assumption that I have to take, or what value should I substitute. So if you observe, you have sine inverse outside, right? That means I want sine inside so that I can use the property sine inverse sine changes to only the angle, right? So what I'll do is let x equal to sine theta. If you had cos inverse outside, you could have taken cos theta and done the sum. You would still get the answer. Okay. So we have also, by chance you do not know what to substitute sine or cos, just pick up any value, sine theta or cos theta, and substitute. It shall give you the same answer. Okay. Also, y is equal to sine inverse of bracket 2 sine theta under root of 1 minus sine square theta. Now, what is 1 minus sine square theta? It is cos square theta, right? So, we'll have sine inverse of 2 sine theta. Root of cos square theta will become cos theta. What is 2 sine theta cos theta? It is sine 2 theta. So, sine 2 theta. Here we've got sine inverse sine. So, it cancels out and get y equal to 2 theta. Let us substitute what is theta. It is sine inverse of x. So, y is equal to 2 sine inverse of x, right? dy by dx is equal to 2. What is sine inverse x derivative? It is 1 upon root of 1 minus x square, right? So we get dy by dx is equal to 2 upon root of 1 minus x square. Okay, second. Yes, 2 upon root of 1 minus x square. That is your fourth question. Okay, let's move on to the next one, the fifth one. Cos inverse of 3x minus 4x cubed. Now, there is a formula. We have 3 cos theta, sorry, 1 second. Yeah, 3 sine theta minus 4 sine cube theta. Okay, we have something like that, which gives me sine 3 theta. So, what is the formula I know? I know that sine 3 theta is equal to 3 sine theta, okay, minus 4 sine cube theta. Okay, I have this as my formula. Now, if you observe the question, it says 3x minus 4x cubed, right? So, can I use this identity? Can I use this identity, sine 3 theta, 3 sine theta minus 4 sine cube, right? So, only in place of x, I have sine theta here. So, I'll just do the substitution. Let x equal to sine theta. Okay. Therefore, theta is equal to sine inverse of x. This is to be written important. Okay. Now we will write the cos inverse. So cos inverse 3 sine theta minus 4 sine cube theta. And from the formula, what is that? It is sine 3 theta. So y is equal to cos inverse of bracket sine 3 theta. What we can observe here is they are opposite ratios. So we are going to write the complement of the inner angle, that is cos of pi by 2 minus 3 theta. Okay, so we are going to get y equal to as pi by 2 minus 3 theta. Okay, let us substitute theta. It is sine inverse of x, right? So do this here. So y is equal to pi by 2 minus 3 sine inverse of x, right? dy by dx then will be equal to 0 minus 3 sine inverse x derivative is root of 1 minus x square, right? So my final answer is dy by dx is equal to minus 3 upon root of 1 minus x square. Clear? So here we finish with question 9, 5 questions. Okay, I'll finish with this exercise in the next session. I'm sorry, and begin with logarithmic differentiation. Okay, if you have any doubts regarding this session or any of the previous sessions, do write to me. I'll solve the doubts for you. Thank you very much.